In this part of my lecture, I will show how to implement Xbar and R control charts for process monitoring. For this purpose, I will use the Minitab statistical software. Although I will talk about the implementation of the Xbar and R control charts, the same steps apply also to the Xbar and S control charts. Let's reconsider the flow with measurements from the semiconductor manufacturing. In this example, we had 5 measurements from 5 wafers in each sample. Again, let us have 25 samples or observations that will be used in phase 1 to design the Xbar and R control chart. To ease the process, I already entered the data in the Minitab worksheet, as can be seen here. On the left, you see the data entered as 25 rows, each row consisting of 5 columns, and each column is corresponding to a measurement of 1 wafer. An alternative way to enter this data is shown on the right. Here we have samples indicated as a column here, and we have observations as another column. In the sample column, we have 5 ones, for example here, indicating that these observations to the right are coming from sample 1. So basically, these 5 observations are the 5 observations given in this row. The rows are transposed to columns, and they are combined together to have 2 columns of observations. So we have alternative formats that we can consider for entering the data. Now, let's do some calculations. For example, suppose that we are interested in the mean of the samples. So let's see how we evaluate or how we calculate the sample averages. Simply go to calculate. You can select raw statistics here. Simply we can say mean. Input variables should be selected. We select the columns C2, C3, C4, C5, and C6, which correspond to the 5 wafer measurements. We select them. They are written here. And we need to identify where these results are stored. So let's see. C7 is empty, so let's write column 7 to store the results. As you can see, we have the mean values of each sample, and let's say this is mean, or we can say Xbar. Similarly, for each row, we can have the range values calculated. Let's see how we do that. Again, we go to calculate. We can simply select row statistics. We can select range here. Input variables are the same, so I'm not going to make a change. This time we can store the results in column C8. And here we have the range values. Although I illustrated this, we don't need to make these calculations for the control chart implementation. Before doing that, I would like to show you one other thing. We talk about the normality of the observations, or we talked about the central limit theorem and say that the sample averages tend to be normally distributed. So Xbar values are assumed to be normally distributed. How can we test this? It is again simple. We go to Stat this time. We go to Quality Tools. And here you will see individual distribution identification. So we can fit several distributions by using this tool. So let's select which column we are interested in. We will use Xbar column. And the subgroup size is 1 here, so I'm not going to enter that. We can specify which distribution that we will consider. Let's consider the normal distribution. here. We have 25 sample averages, and let's see if they are normally distributed. I press OK, and we get the probability plot for the Xbar values. As you can see, the values are within the 95% confidence interval shown by blue here. And we also have some tests for normality. The p-value here is 0.55. If we consider a significance level of 0.05, in this case, we can say that we cannot reject the distribution to be normal. So we can consider normal distribution to be appropriate in this case by looking at the goodness of fit test results, or also by looking at the probability plot here, where the red points tend to plot on the line in the center, and the red dots are within the confidence intervals provided for this plot. So simply we can consider normal distribution as an appropriate assumption in this case. So now let's consider how we do the Xbar and R control charts. To do that, we again go to Stat. Here you see the control charts. We select variables charts for subgroups. As you can see, we have several options. And here I will select the Xbar and R control chart. Now we need to first define the observations. Here we have an option. It says all observations for a chart are in one column. This basically stands for this case to the right. Let me use the other one and select this one. Observations for a subgroup are in one row of columns. And this option considers this case. So let me go with that. I need to select the columns this time. Again, I select column C2 to C6, where C2 corresponds to wafer 1 measurements and C6 corresponds to wafer 5 measurements. I select them and you see them here. Now, I will go to I will skip the details, but for you, for example, labels may be interesting. You need to give a title to the chart. You can use subtitles. You can use footnotes, etc. And you can consider this. Let's say this is flow with measurements control charts, just for illustration. Basically, we will have most of our options given by this stuff, Xbar and R. Let's see what we have. Now here, in case you know the parameters, or in some cases, this is the standards given case, you can enter the mean and standard deviation of the process here. If you don't enter these values, we will have estimation. So if you click the estimate tab, you have two options. You can use R bar chart or you can use full standard deviation. As usual, let's consider the R bar chart. Here, there's a tick. It says use unbiased constant. So by default, it will consider the D2 constant. So D2 constant will be automatically used in this example. We can consider some observations to be excluded, or we can also define which variables, which observations will be included when estimating the parameters. Here, we have two options, as you can see. One is omit the following subgroups when estimating the parameters, and the other one is use the following subgroups when estimating the parameters. So let's leave it like this because I don't want to omit any subgroup, so I leave this empty, but I selected our bar chart. S limits are the standard deviation limits that we consider. I will consider the traditional 3 sigma limits. So by default, it's the standard deviation limits is given here as 3. So I'm not going to write anything. There are different tests. This is the standard 3 sigma limit test that we consider. But if you are interested in performing sensitizing rules, you can consider the options given here, or the Western electric rule. So Minitab allows us to implement sensitizing rules or the Western electric rules. I will go with the basic default case where one point is greater than k, which is selected to be 3 here. So 3 standard deviations from the center line. So this is the default control. We can alternatively define stages here, but this is phase 1, so I didn't define it, but soon I will show how to do that. If the data is not normally distributed, Minitab can be used to normalize transformed observations by using a box-Cox transformation, so the observations can be normalized. Display shows gives options to display the control chart that will be plotted. So, for example, we here by default we consider all subgroups to be displayed on the control chart, but alternatively, you can define how many observations or samples are plotted on the control chart. We can split the plot into segments, for example, based on a stage of the control chart. I will not do that right now, but this is an option for you. And we can display control limits and center line labels for all stages. So let's tick this one. Storage, if you would like to store some values, for example, mean, standard deviations, in the worksheet, you can click this one. So let me simply press OK and press OK here. You have the control chart. Here we have our control charts. In the worksheet, you see the mean and standard deviation because we wanted to store these values. These are our control charts. The top one is the Xbar control chart. The bottom one is the range control chart. Sample range and sample mean values are given. As can be seen here, the upper control limit is found to be 1.6932. The center line or the grand average is 1.5056. And for the R chart, we have the values. I cannot read it well, so I will take it a little bit below. The upper control limit is 0.6876, and the lower control limit is 0. Now, this is phase 1 data, but by looking at the plots, we don't see any observations plotting outside the control limits. This is very close to the upper control limit, but it's not out of control. So from here, we can say that, okay, the trial control limits given here can be considered for phase 2 implementations. And we can consider the process mean to be estimated as 1.5056. And if we want to have the estimate of the process standard deviation, we can consider R bar given here and divide it by D to have a value for the process standard deviation. So this is our phase 1. We can make a lot of changes on this plot to make it look nicer. Here we have the title of the chart that we already defined. For example, if you want to change the background color, you can click that part, say custom, and for example, we can make that one. So it's better now. Alternatively, for example, you can click on the control limits. You can make them custom. Let's have dashed lines. Let's have color, which is black again. And let's increase the size to 4 to have better documentation. So as you can see, we can alter the figures a lot. And we can, for example, make changes here. For example, instead of sample mean, we can write sample average, for example. And you can take this off and we can make other changes. So basically now we have an Xbar control chart and an R control chart for implementation. As all the points plot within the control limits, I will take these trial control limits as phase 2 control limits. So I will not do any revisions or iterations of the control chart in this example. Now, we designed the control chart. We have the upper control limits given here. Basically, we have the process mean, process standard deviation, or R-bar value, which should be divided by 2. Now, let's do a phase 1 implementation. For this purpose, in this example, I had 25 samples, as can be seen. Now, let me open another file that I prepared for you. This is the phase 2 data set. So I'm going to change the worksheet. Now, in this worksheet, we have the phase 2 implementation. Basically, the difference between these two worksheets are main differences. We have additional observations. In the phase 1 data set, we had 25 samples. Here, in addition to the 25 samples that are used in phase 1, we have additional samples that are going to be used. So we have additional 20 samples here that would represent phase 2. So let's see how to implement the control chart in phase 2. Again, we go to start, we go to control chart, we select variables charts for subgroups, and we go to Xbar and R control chart. As you can see, if you prefer, instead of Xbar and R, you can use the Xbar and S option here, which will be the same thing as in terms of implementation. So here again, we need to show where our data are. So observations for a subgroup are in one row of columns. Again, we can select these columns. We can go to Xbar and R options this time. I already estimated the parameters in phase 1. So let me write the mean that I already obtained in phase 1. The value for the mean was 1.506. Of course, we need to estimate standard deviation. We had the R-bar value. Now we need to divide the R-bar value by the appropriate D2 constant. We had a sample of size 5, so correspondingly, the D2 constant is 2.326 for this example. R bar over D2 R bar in our example is 0.32521. D2 is 2.326. So we have the R bar sigma hat estimate R bar over D2 as 0.1398. So let me enter that here, 0.1398. So as I enter the parameters, Minitab will not do any estimation in this case. I'm just plotted. I would like to show one other thing here. In entering the data, I entered the phase data. So as can be seen here, I labeled the data as phase 1 or phase 2. So the first 25 observations are labeled as 1 in the phase column, and the rest are labeled as 2 to represent the label for the phase 2 operation of the control chart. This is just for the plotting of the observations on the control chart, or to better illustrate the concept. Again, I go to start quality control charts, variables charts for subgroups, Xbar and R. I select again I define the observations as given here. Let's go to Xbar and R options. We define mean to be 1.506. Standard deviation is R bar over D2. which is going to be 0.1398. So we will not, as I enter the parameters, the Minitab will not estimate them. But here I will go to stage and define stages. And for stage, I will select column 1 or face column. This will show the data in two stages. So it will be a better display for us. I will not store anything in this case, so I will delete these. I will just display as a single line, single plot without splitting. So let's click OK. And you see that our data set is, our control chart is given here. To the left of this dashed line, we have the phase 1 implementation, where we estimated the parameters and designed the control chart. Defined the upper control limit center line and the lower control limit. And to the right, we have the phase 2 process. In this case, in phase 2, we didn't change the control limits. We used the control limits defined in phase 1. So we extended these lines, and now we have 2 out of control observations. So in phase 2, of course, we need to identify the root causes of these and take corrective actions. So here we have sample 43. As you can see, if you go on the top of the points, we will have the indicators seen. So this is label or sample 45. This is sample 43. This is sample 45. We have 2 out of control conditions for this case. This is the example from the textbook. So I recommend you to enter the data for the same example. You can consider 2 formats, the 2 formats that I already showed you for entering the data. And please practice on the Xbar and R control charts, as well as the Xbar and S control charts. And please play with the functionalities of Minitab to have better idea about what you can do with Minitab. On the other hand, you can do the same implementations by using Microsoft Excel or some other software